The National Electrical Code, or NEC, does not contain a specific requirement stating that a building must be weathertight, meaning having the roof installed and windows in place before electrical rough-in can commence. The NEC focuses primarily on the safe installation of electrical systems to protect people and property from hazards such as electrical shock and fire. It addresses aspects like wiring methods, overcurrent protection, grounding, and equipment installation, but it does not typically delve into the structural integrity or weatherproofing status of the building itself as a prerequisite for electrical work. However, it is crucial to understand that while the NEC might not impose this specific weather tightness mandate, local jurisdictions and building codes often have their own supplementary regulations. These local rules can indeed stipulate that a building must reach a certain stage of completion, including being weathertight, before certain types of construction activities, such as electrical rough-in, can begin. The reasoning behind such local requirements often revolves around protecting electrical materials and installations from the elements during the rough-in phase. Exposure to rain, wind, and extreme temperatures can damage wiring, boxes, and other components, potentially leading to safety hazards and premature failure of the electrical system. Therefore, local inspectors might enforce weather tightness to ensure that the electrical work is performed in a controlled environment, minimizing the risk of environmental damage. It is imperative for electrical contractors and installers to always consult with the local authority having jurisdiction, or OJ, to determine if there are any specific requirements regarding weather tightness before commencing electrical rough-in. These requirements can vary significantly from one location to another, and failure to comply with them can result in delays, rework, and even fines. The AHA can provide clarity on local interpretations of the NEC and any additional regulations that must be followed. In addition to local codes, other considerations might influence the timing of electrical rough-in in relation to the building's weather tightness. For example, project specifications or contractual agreements could stipulate that the building must be enclosed before electrical work can begin. General construction practices also often favor completing the building envelope before starting interior work to protect materials and workers from the element. From a practical standpoint, performing electrical rough-in in a weathertight building offers several advantages. Firstly, it provides a more comfortable and controlled working environment for electricians, improving productivity and reducing the risk of weather-related delays. Secondly, it helps to protect electrical materials and installations from moisture, dust, and debris, ensuring the long-term reliability of the electrical system. Thirdly, it allows for more accurate layout and installation of electrical components as the building's interior spaces are clearly defined. While the NEC does not explicitly mandate weather tightness before electrical rough-in, there are several sections that indirectly relate to the protection of electrical equipment and wiring from environmental factors. For example, Section 300.5 addresses the protection of underground wiring from physical damage, including moisture and corrosion. Section 310.8 specifies the types of insulation that are suitable for wet locations. Section 410.10 addresses the installation of luminaires in damp or wet locations. These sections highlight the NEC concern for the effects of moisture and other environmental factors on electrical systems, even if it does not explicitly require a building to be weathertight before rough-in. To further elaborate on the NEC and its relevant sections, it's important to understand the overall structure and purpose of this code. The NEC is a comprehensive set of standards developed by the National Fire Protection Association, or NFPA, to ensure the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect advancements in technology and changes in industry best practices. The NEC is not a law itself, but it is widely adopted by state and local governments as the basis for their electrical codes. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Chapter 1 contains general requirements such as definitions, scope, and administration. Chapters 2 through 7 cover specific types of electrical systems and equipment, such as wiring methods, overcurrent protection, grounding, and special occupancies. Chapter 8 deals with communications systems, and Chapter 9 contains tables and examples. When determining whether to proceed with electrical rough-in before a building is weather-tight, it is essential to consider the potential impact of environmental factors on the electrical system. Moisture is one of the most significant threats to electrical installations. It can cause corrosion of conductors and equipment, leading to electrical failures and safety hazards. Water can also enter electrical boxes and raceways, creating a path for electrical current to flow to ground, resulting in ground faults and potential electric shock. Dust and debris can also accumulate in electrical equipment, causing overheating and malfunctions. In addition, extreme temperatures can affect the performance and lifespan of electrical components. High temperatures can cause insulation to degrade, reducing its ability to protect conductors from short circuits and ground faults. Low temperatures can make wiring brittle and more susceptible to damage. Therefore, it is crucial to protect electrical materials and installations from these environmental factors during the rough-in phase. One way to mitigate the risks associated with performing electrical rough-in before a building is weather-tight is to use appropriate materials and installation methods. For example, conductors that are rated for wet locations should be used in areas that are exposed to moisture. Electrical boxes and fittings should be watertight or rain-tight to prevent water from entering. Raceways should be sealed to prevent the ingress of moisture and debris. In addition, temporary protection measures can be implemented to shield electrical work from the elements. Tarpaulins, plastic sheeting, and other coverings can be used to protect wiring and equipment from rain, wind, and dust. Temporary heating or cooling can be used to maintain a stable temperature in the work area. Furthermore, regular inspections should be conducted to identify and address any potential problems. Wiring and equipment should be checked for signs of damage or corrosion. Any water or debris that has accumulated in electrical boxes or raceways should be removed. Any temporary protection measures that have been compromised should be repaired or replaced. In summary, while the NEC does not explicitly require a building to be weather-tight before electrical rough-in can begin, local codes and regulations may impose such a requirement. It is essential to consult with the local authority having jurisdiction to determine the specific requirements in your area. In addition, it is crucial to consider the potential impact of environmental factors on the electrical system and to take appropriate measures to protect electrical materials and installations from damage. By following these guidelines, you can ensure that electrical rough-in is performed safely and effectively, regardless of the building's weather tightness status. It is also worth noting that some electrical inspectors may interpret certain sections of the NEC to imply a need for weather protection during rough-in. For instance, Section 110.12, Mechanical Execution of Work, states that electrical equipment shall be installed in a neat and workmanlike manner. An inspector might argue that leaving electrical work exposed to the elements is not in accordance with this requirement. Similarly, Section 300.4, Protection against physical damage, requires that wiring and equipment be protected from physical damage. An inspector might contend that exposure to rain, wind, and debris constitutes physical damage. While these interpretations are not explicitly stated in the NEC, they highlight the importance of considering the potential for environmental damage during rough-in. Ultimately, the decision of whether to proceed with electrical rough-in before a building is weather-tight is a matter of professional judgment and compliance with local codes and regulations. It is essential to weigh the risks and benefits of each approach and to take appropriate measures to protect the electrical system from damage. Consulting with the local authority having jurisdiction and other qualified professionals can help to ensure that the work is performed safely and effectively. Understanding the purpose and scope of the NEC is crucial for electrical professionals. The NEC is not intended to be a design manual, but rather a set of minimum safety standards. It is the responsibility of the electrical designer to ensure that the electrical system is properly designed to meet the needs of the building and its occupant. The NEC provides guidance on many aspects of electrical design, but it does not cover every possible situation. Therefore, it is essential for electrical designers to have a thorough understanding of electrical engineering principles and to exercise sound judgment when making design decisions. The NEC is also not intended to be a substitute for proper training and experience. Electrical work should only be performed by qualified individuals who have the necessary knowledge and skills. Electrical contractors should ensure that their employees are properly trained and supervised, and that they have access to the necessary tools and equipment to perform their work safely and effectively. The NEC is a living document that is constantly evolving to reflect advancements in technology and changes in industry best practices. It is essential for electrical professionals to stay up to date on the latest changes to the NEC and to understand how these changes affect their work. The National Fire Protection Association offers a variety of resources to help electrical professionals stay informed about the NEC, including training courses, publications, and online forums. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These include local building codes, state electrical codes, and federal regulations. It is essential for electrical professionals to be familiar with all of the codes and standards that apply to their work and to ensure that their installations comply with all applicable requirements. The enforcement of electrical codes and standards is typically the responsibility of local building inspectors. Electrical inspectors review electrical plans, inspect electrical installations, and issue permits to ensure that the work is performed in accordance with the applicable codes and standards. Electrical inspectors play a vital role in ensuring the safety of electrical systems and protecting the public from electrical hazards. In conclusion, the question of whether a building must be weathertight before electrical rough-in can begin is complex and depends on a variety of factors, including local codes and regulations, project specifications, and the potential impact of environmental factors on the electrical system. While the NEC does not explicitly require weather tightness, it is essential to consult with the local authority having jurisdiction and to take appropriate measures to protect electrical materials and installations from damage. By following these guidelines, you can ensure that electrical rough-in is performed safely and effectively, regardless of the building's weather tightness status.